Hello and welcome to this presentation on the application of autonomous AI to platform-to-consumer food delivery, focusing on Deliveroo as a company to direct any recommendations. To begin with, please allow me to provide some key definitions that will appear frequently throughout the presentation. Have untapped new sources of demand by offering consumers a platform to compare offerings and order meals from many restaurants. The players in this category, through providing their own logistics, have disrupted the market by tapping into new revenue sources, namely higher-end restaurants that traditionally did not deliver food. In fact, the market food delivery sector is currently valued at £73,279 million, equivalent to 1% of the total food market and 4% of food sold through restaurants and fast food chains. This is predicted to grow at 9.3% annually. Where this market is subdivided into traditional delivery by restaurants and new delivery by actors such as Deliveroo, the total market for new delivery currently stands at £28,243 million in revenue. The penetration of this new delivery market is therefore estimated to increase from 7.5% in 2016 to 10.5% in 2023. The implications of such are that firms in the platform to consumer, such as Deliveroo, are looking at a growing market rate of 9% and an increasing market penetration on top of that. Therefore, as McKinsey estimates, firms within this sector are looking at approximately 30% EBITDA gross margins. Deliveroo currently has a 12% share in the food delivery app market. Its main competitors as of 2017 are Just Eat, Hungry House, and One Delivery. Deliveroo is a British disruptor and startup success story founded in 2013 by Will Shue and Greg Arlowski. The business model was inspired by their own experiences of late nights at the office, within the banking sector, and a lack of high-end delivery options. The company now operates in more than 200 cities and 12 countries, and employs over 35,000 riders globally. Let's now take a look at the business model of Deliveroo and the problems that it is facing. Despite having a 12% market share in a high-growth sector in particular, with typical net EBITDA margins at 30% as estimated by McKinsey, Deliveroo is making losses. In 2017, it announced that their net loss before tax was £183.7 million, and whilst the company is valued at £1.5 billion, this reflects the growth in the market and investors' optimism, or at least it's supposed to. The lack of revenue-generating activity may hint at inefficiencies within Deliveroo's business model. In fact, a major share of the costs incurred within the model is incurred through the labour costs of last-mile delivery, and these can amount to a cash drain if the platform cannot achieve a high enough rate of utilisation. The current costs of remuneration within the model comes at £10 per hour. Furthermore, Deliveroo's business model depends on flexible working arrangements of its riders. Due to this, therefore, the company has recently begun facing surmounting legal obstacles, for instance, lawsuits in employment right cases resulting in costly payouts. Okay, so what's this got to do with autonomous AI? Well, Deliveroo is an innovator within its sector. Its competitive advantage and growth is reliant on constant innovation. It already uses data to support its algorithmic decision-making, and it also uses a machine learning algorithm, it's known as the Frank Dispatch Engine, to calculate and best match riders and orders and predict food preparation time based on the historical data. Therefore, because of Deliveroo's culture and its reliance on innovation, as well as the last-mile delivery inefficiencies within its current model, we believe that the implementation of autonomous AI has the potential to add much value to Deliveroo's operations. Introducing last-mile delivery robots might present the way to deliver on Will Shue's core aspirations of growth through ambition and innovation, and it may also solve the most pressing last-mile delivery labour costs and inefficiencies currently limiting the profitability of the platform. Essentially, last-mile delivery robots are, at least in terms of the technology, the same as autonomous vehicles, because that's essentially what they are, except instead of delivering people, they're delivering food. The bots utilize GPS, radar, cameras, and ultrasonic sensors, and through artificial intelligence are capable of level 4 or level 5 automation. That is, high-level automation or full automation, respectively. But how do these inputs actually result in automation? The answer lies in artificial intelligence, and, in particular, neural networks. Under the hood of autonomous vehicles are what's known as neural networks. These aren't physical components, however. Instead, they are more of a system used to infer patterns from available data, in a way similar in context and function to the neocortex of our brain. For instance, given, say, an image as an input, the neural network aims to process it. The lowest layer of the network is the input, for which it aims to identify small features within the image. If you keep on feeding it images, each layer learns something different, and passes it onto the next layer via activation functions. This is essentially in order to identify what the image is, or at least to identify different features within the image. In the last layer, you ultimately have a function that tells you how accurate your neural network is against a label. This process is essentially utilizing a representative dataset in a process known as training. This process is therefore essential to the proliferation of autonomous vehicles, and therefore in our case, delivery robots. For instance, a dataset must comprise a sufficient amount of any possible driving, weather, and simulation patterns. The last-mile delivery bots utilize GPS, radars, 360-degree cameras, and ultrasonic sensors, as mentioned previously. These inputs all go through the algorithmic training process, which in effect allows the vehicle to identify patterns in the environment. A repetitive loop, called the perception-action cycle, is created when the autonomous vehicle generates data from its surrounding environment and feeds it into the intelligence agent, who in turn makes decisions and enables the autonomous vehicle to perform specific actions in that same environment. All of these form the digital sensorium, through which the delivery bot can see, hear, and feel the road, infrastructure, and any other vehicles or object that may be on or near the road or pavement, just like a human driver would pay attention to the road whilst driving. This data is then processed with supercomputers, and data communication systems are used to securely communicate valuable information to the autonomous driving cloud platform, aka the intelligent agent. This essentially utilizes the AI algorithms in order to make decisions, and also store and memorize previous decisions made. Based on these decisions, the robot is able to detect objects in the road, for instance, and maneuver itself along the pavements before reaching its customer. It should, however, be noted that at this stage we are not referring to necessarily the mechanical application of this technology, solely the application of artificial intelligence. Anyway, any ride is recorded and stored in the database to help the intelligent agent make more accurate decisions in the future. The greater the number of perception action cycles, the more intelligent the agent becomes, resulting in a higher accuracy of decision-making overall. Simply put, the more deliveries made, the better the robot becomes. Similarly, the more robots on the road, the more data is created. Starship Technologies is revolutionizing last-minute deliveries by using autonomous robots to provide the world's first on-demand delivery services. They are both a provider of the infrastructure as well as a service provider. Those knee-high robots you can see in the photo are equipped with 6 wheels, a GPS, a radar, cameras and ultrasonic sensors to drive autonomously and carry items under 10 kilograms in their locked storage compartment. They can deliver packages within 6-mile radius and have the speed of 6.4 kilometers per hour. And since the robots are electronically powered, Starship's delivery system is clean and environmentally friendly. Customers use Starship's app and choose the products that they wish to be delivered, ranging from food from the partner restaurants and supermarkets to online shopping packages. The time they wish to get the package is conveyed, and the delivery location is set using a pin drop. Once the package arrives at the customer's chosen location, the app will notify customers and unlock the storage compartment via the use of a unique code. The app also provides full-time tracking system of the delivery via an interactive map. Starship's on-demand delivery service is currently available in Milton Keynes, UK, where Starship has partnered with the Co-op and Tesco to provide online groceries. It's also available in California, where deliveries include the use of Starbucks and Dunkin' Donuts. Till February 19, there have been 30,000 deliveries completed. Pretty impressive for a startup. Artie, the company's co-founder, summarized the company's valuation as convenience and low cost. For instance, Starship's US delivery costs are currently $1 per delivery, and the customers in the UK can opt for a subscription model for unlimited deliveries. The next case is Twinswheel. Twinswheel is a French startup launched in August 2016 that deals with industrial and last-minute urban delivery droids. The droids are equipped with a LiDAR and a 3-dimensional camera which enables self-driving. It is designed to carry a load of up to 40 kilos and can cruise to a speed of 7 kilometers per hour, whilst its delivery range is 10 kilometers. It's extremely agile since it continuously learns about the changing environments, and as such is built in a way that is highly empathetic. The mission of the company is to assist workers and technicians in heavy industry and to prepare Twinswheel to become an important agent in last-mile urban logistics by cutting the costs. Currently, it operates in Paris, Toulouse, Montpellier and Lyon in France and has prominent clients such as La Poste, the French postal network, which is currently trying to reduce costs of the last-mile delivery by 60% according to our research, the SNCF, which is the French rail network, Renault Nissan, and the automobile company, and also Siemens, which is the German industry player. So clearly there's use of the delivery robots in last mile delivery. So now we've explored some of the case studies. How exactly can the autonomous robots benefit the business model of Deliveroo, especially in terms of profitability, and help them achieve their objectives? Well, on the revenue side, last mile delivery robots have the potential to enhance customer experience. It's somewhat of a gimmick feature to have a robot to deliver to your door, and it would potentially appeal to the tech savvy in particular, which in a sense provides a competitive advantage over competitors and thus increasing the number of orders. However, it stems a little bit deeper than this. If targeting small suburban areas, autonomous AI robots might expand the user base further, from large cities to smaller suburban areas as well. This creates the opportunity to essentially tap into a new market segment, which is the smaller suburban restaurants that previously didn't deliver, or who are particularly reliant on the old method, which is to have a driver deliver the food in a car, for instance, like in the olden days, or at least 10 years ago. This is essentially how Deliveroo came about, by offering delivery services to previously uncovered groups of restaurants. This, again, has the potential implication for an increased volume of orders, and thus revenue, and the additional advantage of supporting local businesses as well. An additional advantage would also be the environmentally friendliness of the robots when compared to traditional mopeds, for instance, especially in the age of woke capitalism. All of these features would add value by targeting a new demographic, the suburban, environmentally friendly, tech-savvy crowd. On the cost side, it's more interesting. The robots have the potential to substantially decrease the labour cost in the last mile delivery. A predicted decrease of £1 per meal /per ride would result in substantial cost decreases across the business. Furthermore, integrating AI into Deliveroo's current deep learning algorithms has the potential to further achieve a higher utilisation rate and get rid of any inefficiencies within the supply chain. However, of course, this comes with a lot of risks, and a lot of costs as well. A major factor for consideration is the cost of adopting this technology in the first instance, not least the robots themselves, but also the artificial intelligence that's required to train and maintain the operations. Extensive computing capacity is crucial in this case, as is a large amount of trainable data in the first instance. For instance, the environmental inputs that we mentioned earlier in relation to neural networks. Outsourcing these things is extremely expensive, but it's also probably the best way for Deliveroo to achieve this in their operations. Outsourcing these things is also extremely expensive. Additional tangible costs, including the cost of insuring the robots, for instance, needs to be considered, whilst intangible wider costs might include the uncertainty of future regulations in relation to the robots. Whilst the robots are currently legal in the UK, so long as they don't exceed 10 kilograms and travel at more than 6 kilometers per hour, there's a certain uncertainty of how autonomous AI will be regulated in the future. The potential of autonomous AI to Deliveroo essentially depends on agile implementation. This will offset the risks imminent to the adoption of the technology. With regards to a joint partnership, as we can see in the diagram, approaching Starship, for instance, and suggesting to collaborate and form a joint venture would secure a source of technology for Deliveroo. By approaching Starship, there could well be a deal to be reached whereby Deliveroo use their robots and AI, and Starship take a percentage cut of their delivery costs. However, it should be noted that since Starship is already now seen as a potential or at least a future competitor, as they themselves have a platform to consume a logistics network in Milton Keynes, Deliveroo must be prepared to make significant concessions. Alternatively, Deliveroo might have a look into alternative technology providers, ones that provide the infrastructure but are not necessarily providing the service in which Deliveroo are trying to provide themselves. In terms of financing, Deliveroo's main issue is that they are already capitally constrained, given that they are a startup in particular, and investors are unlikely to inject further capital into a project that is highly capital intensive, as well as risky. Purchasing the robots itself is a huge financial drain on the resources of the company, let alone an unprofitable one. The scale of the company's crowdsourcing up to date might mean that this stream of financing is exhausted in the short to medium term. Similarly, Deliveroo do not have the internal capacity in terms of data scientists to orchestrate AI solutions on this level. Therefore, they would have to outsource the AI project to a specialist company, and while some of these issues can be solved through a joint venture, they also rely on the possibility of securing one. Last-mile delivery robots will only work well in suburban areas, as seen in Milton Keynes. This is a fundamental point that we need to consider in any recommendation going forward. Footfall or congestion is a huge consideration in large cities such as London. This is arguably a good thing, however, as we've seen, Deliveroo only focuses on major cities. Providing an extra service using robots may be beneficial in suburban areas, which will generate extra revenues and satisfying currently untargeted customers. We therefore propose that if Deliveroo were to adopt this technology and implement AI robots, then they would not do so in congested areas such as London or Birmingham or Manchester. So I guess ultimately the viability of utilizing AI in Deliveroo comes with limitations. That said, that doesn't mean that the limitations cannot be overcome, as we see with many technologies. As we've explored throughout this presentation, it may be the case that Deliveroo would be able to benefit handsomely from the use of robots, particularly in suburban areas, if it's financially feasible. Although it may be best to be trialled in the area first, of course, before adopting widely, and therefore we suggest that if Deliveroo do continue to adopt this strategy, then agile implementation is the best method forward. Thank you.